Welcome back to Mastering Docker 2025 from developer to production. And in this part of the course, I wanted to step through the architecture of containers and container images. Now, it's important that you understand how each of them work, but also how they relate to each other. Now, we have got a lot of things to cover, so let's jump in and get started. The first thing that I want to cover is the high-level relationship between the container and the container images. A container image or Docker image should be thought as a read-only immutable template. When you create them, they don't change. But if you do change them, you are actually making a new image. But container images are used to run containers, and containers need storage. So how does that work? Well, let's say that we launch a container from this container image. What actually happens is a writable layer is added. Conceptually, imagine this as attached to the container. It means that any data writes which happen inside the container rather than changing the image itself are written to this layer. And this is the default way that containers have a form of local storage. This writable layer is what makes one container unique from another, where both use the same container image. If we launch another container from the same image, but that container gets its own unique writable layer, making it, that is, the container on the right, unique from the container on the left. Writable layers are linked to the lifecycle of the container. They don't persist and they don't offer a way to move data between containers. Think of them as isolated to a container. Additionally, writable layers use a union file system. They have a driver specifically to allow shared read-only image and then any written data to be stored in this separate layer. Now this does come up with a slight performance hit, and they are also tightly coupled to a host so the data cannot move easily. If you need to share data, there are other more advanced types of storage that will be covered elsewhere in the course. Container writable layers are just there to allow a container to have its own system state. Now, talking about layers, I should probably talk more about that. So let's look at that next. So far, I have talked about Docker images as though they are a monolithic thing. They are actually not. Images are a collection of independent file system layers. Let's review how this works. For our application image, if we peek inside, what we might see is three different file system layers. Layers within Docker images are differential, meaning each layer only contains the differences from the layer below. Let's say this bottom layer is a base Linux file system layer, so it contains the files required to boot a Linux container. The middle layer contains some runtime environment files and libraries which our application needs. And notice how this is less data shown as 1 cube versus 3 on the layer below. This file system layer only contains data which is changed from the bottom layer. At the top, we have our application layer which also contains some data. But this doesn't change anything from the layers below. Instead, it adds new data. Each of these are separate layers, but when working with images, because the image consists of these three independent layers, what a Docker container might see is this, where it sees what is in effect one single store of data containing these four blocks. But in actual, they are each taken from independent layers. Each layer stores the differences in data. And from a Docker container perspective, it reads all these individual layers and interacts as though it was one store of data. And because these layers are treated as individual things, it helps to avoid unnecessary uploads or downloads. For example, if you run a Docker pull to pull down an image, if you already have any of the layers, they don't need to be pulled down again. Now, at high level, that's how Docker images and layers interact with the containers. So our Docker image is read-only and is immutable. And each image consists of number of different file system layers that are all used together to form an image. But crucially, these layers are treated as separate things. They can be reused. And when you're doing Docker pull or push operations, you will experience later in the course, you will see that these operate individually on layers of images. Now, don't worry, if this seems confusing as you move through the course, you are going to get more and more in-depth theory understanding as well as the practical exposure for how you can interact with Docker images and layers within those images. For now, that's everything that I wanted to cover in this part of the course. Hopefully it all makes sense. When you are ready, go ahead and move on in the course, and we can continue diving deep into Docker. In the next video, we'll see how we can spin up our Docker container. So thank you and see you in the course.